Hello students, welcome to my YouTube channel R.S.ACADEMY. In last part we have discussed about the atomic spectrum. In this part, that is part number 10 of this chapter 2, structure of atom, class 11. I am Navdeep, presenting my academy R.S.ACADEMY. So in this video we will discuss about the Bohr's theory for hydrogen atom, how the Bohr's theory is applicable to an hydrogen atom, right? So according to this theory, we will talk about the hydrogen atom. That is what the for stationary states for an electron are numbered as n, that is 1, 2, 3 and so on, and also known as the principal quantum number. For example, if we talk about an hydrogen atom, and this is the nucleus, and this is what the various orbits of hydrogen atom. So these electrons are present in these stationary states. So these are the stationary states in which electrons are present, which is named as principal quantum number, that is represented by letter n. Nextly, if we have these stationary states known as orbits, so these orbits have fixed atomic radius or orbit radius. So the radii of the stationary states are expressed as, that is Rn, radius of the n state, is equals to n square into a naught, where a naught is a constant and the value of which is 52.9 picometer. For if we take the value of n as 1, so here we get as 1 square into a naught, that is equals to a naught, that is equals to 52.9 picometer. So the first stationary state, the radius is 52.9 picometer, which is also known as the Bohr radius for an hydrogen atom. Nextly, the energy of these states is given as the En, that is equals to minus RH into 1 by n square, where RH is known as the Rydberg constant, the value of which is 2.18 into 10 raised to the power minus 18 joule. So this is the energy of a particular stationary state. And next is what, if we talk about the this particular stationary states having some electron, and if this electron is removed, so the atom is said to be ionized. And for this ionized hydrogen atom, the n is taken as infinity. Means what, whenever this electron is going to the position that is taken as the infinity, means what, this electron is not now influenced by the nucleus, and that state of particular hydrogen atom is known as ionized hydrogen atom. The next is what, that this theory also applied for the ions having only one electron. Means we can say that this theory of Bohr atomic theory is also applicable to such atoms having only one electron, or having such ions having only one electron in their in the shell. So we'll take example like as helium, that is He+. We talk about helium having only one electron. Whenever it loses one electron, lithium has 3 electrons, but whenever it loses 2 electrons, remaining only 1 electron, and so on. So this theory is applicable for such type of ions. For such type of ions, the energy is expressed as, that is En is equals to minus RH, Rydberg constant, into Z square by n square joule of energy, where Z is what, the atomic number of that particular atom. For helium it is 2, for lithium it is 3, for beryllium it is 4, and so on, right? If we talk about the radius of such ion having only one electron, so radius is equals to what, Rn, that is equals to a naught, that is what, the constant 52.9 picometer, into n square divided by Z, where n is what, the number of electron, and Z is the atomic number of that particular atom. Now if we talk about the velocity, means if we talk about the hydrogen atom, so we have the terms. Very first is what, the principal quantum number. Second is what, the radii of particular energy state, stationary state. That next one is what, the energy. And lastly we have the velocity. The velocity of such hydrogen atom can be precisely calculated, but here there is not a particular formula. But if we talk about the velocity, that is increases if the positive charge on electron increases. Means what, if the charge increases, the velocity also increases. Along with it, if the decrease in principal quantum number, that is if n decreases, so velocity increases or velocity decreases as the n increases. So this is a relation between the velocity as well as the charge and the velocity as well as the principal quantum number. So these are the four terms related to the Bohr's atomic theory for hydrogen atom. Now what is the explanation of this Bohr's atomic theory? So as we know that whenever an electron is taking energy, so it will go from lower energy level to higher energy level, and whenever the energy is emitted, so it will come from higher energy level to lower energy level. So this is what the basic phenomena. Now what happened that according to Bohr's atomic theory, that the radiation absorbed when electron moved from lower energy state to higher energy state, that is from N1 to any of the cell stationary states, and the radiation emitted means here the radiation emitted whenever it comes from higher energy level to lower energy level, but and the radiations or energy absorbed whenever it came or it goes from lower end to higher energy level. Now what happened whenever we talk about these two, the difference in energy means what energy absorbed and energy emitted. So the energy gap between these two states is taken as the delta E is equals to final energy minus initial energy. If we talk about the formula of energy, that is what En equals to minus RH into 1 upon n square, or if we use this formula for all species, so we can say the energy of the final stationary states, that is of minus RH upon nf square, and the energy of initial state, that is what minus RH into Ni square. This is what the energy difference of this electron. Now if we put the value or we taken out the RH as constant, so RH is taken constant and negative sign is solved out, so we are getting as 1 upon Ni square minus 1 upon Nf square by just interchanging the initial and final position. If you are putting the value of RH, that is Rydberg constant, value of Rydberg constant is 2 into 2.18 10 to the power minus 18, or by putting the same thing, that is what Ni initial square minus N final square into joule. So that much of amount of energy is gap found between these two electrons whenever it is energy absorbed or energy emitted. Now what happened if we talk about the frequency of this associated absorption or emission. So the frequency that is nu associated with this absorption or emission, wherever whichever is taking place, is equals to, that is nu equals to delta E by H. This we will discuss, this we have discussed earlier already. So delta E, from this formula we talk about delta E, that is equals to what 2.18 10 to the power minus 18 into 1 upon Ni square minus 1 upon Nf square. So we put the value of this one, so we are getting as RH upon H. H is Planck's constant into 1 upon Ni square minus 1 upon Nf square into Hertz. So the frequency assigned is Hertz here. So this is the frequency. By putting the value of RH, that is Rydberg constant, and that is a Planck's constant. So we are getting the factor as 3.29 10 to the power 15 into 1 upon Ni square minus 1 upon Nf square, and that much of Hertz the frequency. Now the next one is what? The wave number. That is what? If we talk about in terms of wave number, so nu bar is equals to nu by C. Nu we can already find out by this way, that is RH by RH by H into C, that is 1 upon Ni square minus 1 upon Nf square. Or if we put the value of RH, C and H, so we can just solve it out by putting the value that we get as in final product. Finally we get as 1.09677 10 to the power 7 into 1 upon Ni square minus 1 upon Nf square. So this is what the wave number. So these three terms, that is what the energy gap, frequency and the wave number, can be calculated on the basis of these observations. Now if we talk about the absorption or emission spectra, so in case of particular absorption spectra, the NF, that is what the final stationary states, is greater because it's coming from higher energy level to lower energy level than the initial stationary states. So NF is greater than Ni. We put this value, we get delta E, means the energy gap is positive, means we can say here the energy is absorbed. If energy is Positive means energy is absorbed. That's why it is called as absorption spectrum. If we talk about the emission spectrum, so we can say NF is less than Ni, and Ni means initial, or we can say delta E must be negative. Means in case delta is negative, means energy is evolved. That is the emission of or emission spectra is taking place. So this is how we can just judge by this symbol of this energy that the energy is absorbed or emitted or released. So this is all about the Bohr's theory for hydrogen atom. Thank you.